Look at application of matrices in solving system of equation. Matrices can also be used to solve system of equation, and one of the methods that we'll be looking at is the inverse method. The inverse method. So with that, let's consider these two system of equation with two unknowns. We want to use the inverse approach to find the value of what x and then y. Now what we'll be doing here is to write the matrix equation for these two system of equation. So in writing the matrix equation for this system of equation, what we'll be doing is to write the coefficients of what x and y in the form of what matrix. So we are going to have a11, a12, a21, a22. Then after that, we multiply it by what the variables x and then y, and this is equal to what? So this is the matrix equation for these two system of equation with two unknowns. So let's call this matrix matrix A, let's call this matrix matrix X, and let's call this matrix matrix B. So from this we can say that A multiplied by X is equal to what? B. Now we know that X represents what? X is equal to X and then Y. So it means that if you are able to find X, it corresponds to these two unknown variables. So at this very point, we want to make X to stand alone so that we can find these two values. And we have learned that whenever you have a matrix multiplied by its inverse gives you what? A unit matrix. And we have already established in our previous lesson that whenever you have a unit matrix multiplied by what? Any matrix, it gives you what? The matrix back. So if this is a unit matrix and then you multiply it by any matrix, let's say the result is going to be what? The same matrix. So we are going to multiply both sides of the equation by the inverse of A. So we are going to have, so we know that a matrix multiplied by its inverse gives you what? The unit matrix. So we also said that when you have a unit matrix multiplied by another matrix, it gives you what? The matrix back. So you have S is equal to the inverse of A multiplied by what? B. And this is what we refer to as what? The inverse method approach. And this is what we are going to use to solve the system of equation. So we want to solve these two system of equation using what? The inverse method. So first of all, we have to write the matrix equation for these two system of equation. So the matrix equation for this will be, so we have 3, 5, 2, 3. Then multiply it by what? The variable x and y. And this is equal to what? Now let's call this matrix matrix A. Let's call this matrix matrix S. Let's call this matrix matrix B. So this implies that A multiplied by S is equal to what? B. Therefore, we are going to use the inverse method approach, which is this, to find the value of what? X and then y. So first of all, we have to find the inverse of A. And we know that the inverse of A is given as 1 over what? The determinant of matrix A multiplied by what? The adjoint of what? Matrix A. So we are going to first find what? Our determinant. So determinant of matrix A is going to be what? This times this, 3 times 3 minus what? 2 times 5. And that's going to give us 9 minus 10, and we have minus 1. So the determinant of matrix A is what? Negative 1. So we have our inverse of A is equal to 1 all over what? Minus 1. And then to find the adjoint, we are going to interchange the position of 3 and 3. So we have still 3 and 3, and then we negate 5 and then minus 2. So this is the inverse of A. We can simplify to get minus 3. This will give us positive 5, positive 2, and then minus 3. So this is the inverse of A. So once we get the inverse, we multiply it by what? B, which is what? This. So we are going to have our x is equal to what? Inverse of A multiplied by B. So inverse of A we had, and then our B is what? This. And the whole of this is equal to what? X. So we are going to what? Expand the bracket. So we have 3 times. We have negative 3 times 31 plus 5 times what? 20. Then we have this times that. We have 2 times 31 plus negative 3 times what? 20. So we have, this will give us minus 93 plus 100, 62 minus what? 60. So we have 7 and then 2. X is equal to what? X and then y. So this is equal to 7 and then 2. So we can say that our x is equal to 7 and our y is equal to 2. As easy as that. Let's take one more example. So we want to solve these two system of equations using the inverse method. So first of all, we are going to write a matrix equation for this. So we have 5, 3, 2, 4. Then multiplied by x and then y. And this is equal to what? So we are letting this to be equal to a and this x, and then we have what? B. So we can say that a multiplied by x is equal to b. So to find x, we are going to have the inverse of a multiplied by what? B. X is equal to what? The inverse of a multiplied by what? B. So first of all, we have to find our inverse of a using 1 over the determinant multiplied by what? The adjoint of what? A. So we have our determinant of A is going to be 5 times 4 will give us 20. This will give us 6. So our determinant of A will be what? 14. So we have inverse of A is equal to 1 over what? 14. The adjoint, we are going to interchange the position of 4 and then 5. So we have 4. And then we negate the 3 and then the 2. So this is what the inverse of A. We can simplify or leave it at this 0 point. So we have our x is equal to inverse of A multiplied by B. Inverse of A is what? Then we have our B to be what? So we are going to what? Expand the brackets. So we have 4 times minus 11 give us minus 44. And then we have minus, this will give us plus what? 30. Then we have 22 minus what? 50. So we have 1 over 14. And this will give us what? 20 minus 28. So we have our s is equal to negative 14 divided by what? 14. We have negative 20 divided by what? 14. So we have our s is equal to minus 1, and then minus 2. So from here we can see that our s is equal to what? -1, and then y is equal to -2. As easy as that. I'm going to give you one tutorial set. For the video, you try your hands on it. See you tomorrow. Bye bye.